All right, project 2, basic HTML parsing and crawling. The actual portion of this project is not parsing HTML, although most students do spend a good amount of time on that. But the point of this is actually being able to parse it correctly. I'm sorry, let me rephrase it. It's not the tokenizing of HTML that is the part of this exam. It's the process or project. It's the parsing of it and being able to crawl against web pages. I'll try and make the what all that means in a moment. But this project is divided in 2 parts. Build a simple HTML parser that determines if your HTML tags are balanced. So we're going to do simple balancing of a page. This was extremely important in the beginning of the internet because web browsers were very terrible at rendering. And so if your tags were not balanced, who knows what would happen. Next, find the number of web pages you can visit from a certain HTML page. And that's a certain number of unique pages, by the way. All right, to keep things simple for this project, all pages will be on your local machine. I'm not going to force you to write an actual web spider that goes and grabs HTML. The reason for that is I decided to look at the page source of just google.com, and it was pretty horrendous. Back in the 90s, back in the day, we could do a pretty simple web crawler and data structures, but nowadays it's just not going to happen. But you still should learn basic HTML. So it's important to know your HTML tags are balanced, and HTML, if you don't know it already, is pretty simple. Here's the beginning HTML tag, and here's the ending HTML tag. Notice that you start less than sign, the tag name, then the greater than sign. And when you end the tag, you just do the same thing, but with a slash in front of it. Hey, look, here's the body and the body. Here's the bold tag and the bold. So this would just be a web page that just says hello world in bold text. All right, good. This page is balanced because each tag has a begin tag, tag name, and an end tab at the same level depth. So you have bold ends with bold, body ends with body, and most importantly, all the tags in between are begin and end within that tag. Let me show you something that's not balanced. For example, this is not balanced because you begin a bold and then you try and end the bold tag, but you have it ending the body tag, and then you're trying to end the bold here. This is not balanced because the end body tag does not match the begin body tag. How are we doing? All right. So a couple of things. Project 2, by the way, if you go inside of Project 2, there's the pages, and there is some HTML example. So here we have a beginning body. Here's the example, and then here's an anchor tag, which we haven't exactly talked about yet. When I first did this, these students really loved Pokemon. Is that still a big thing?
Mm-hmm. It's still a thing, kind of, but I've lost interest.
You've lost? I mean, it came out when I was 14, 13? I can't remember. So I was just like a year or two too old for it at the time. I enjoyed it, but bold, and then notice we have a starting anchor tag. Hey, look, this anchor tag ends on the same line. That is perfectly fine. It doesn't have to be. In fact, there could be no white space between all this, and that'd still be a legitimate page. All right. While I think most of us understand by example what's going on, I did give you an official parsing table, or I'm sorry. Well, this is called BNF, but we haven't talked about that. I gave you a table explaining how to parse the HTML. An HTML page starts with HTML, then has a body in between, and then the end HTML tag. Body consists of the begin body, some text, and then the end body. Text can be a string, or a string followed by more text, so that means that this is recursive. You can keep adding more text to it. A tag, or a tag followed by more text. Again, that's the recursive part. So a string is possibly an empty string of printable characters other than less than or greater than. All right. I'm going to try and make this easy to parse and tokenize. And by tokenize, I mean actually see that this is a token less than HTML greater than. That's a token, and the token is the beginning HTML tag. And this token right here is the end HTML tag. But I'm trying to make this easy to parse and tokenize, so I'm not going to do any type of crazy escape characters or any back or anything like that. I'm going to make it very simple, because that's the parsing part is not supposed to be the big part of this project. So a string is an empty string of printable characters less than or greater than, because less than or greater than signifies something else. A tag can be a bold tag, an italics tag, or a link tag. A bold tag starts with the bold tag, has some text in it, knows that text can have strings and other tags in it. So your tags can't have more tags in it. And then ends with the, with the end bold tag. Italics is the same thing, but with I. And then a link is in this format. The link is strictly in this format. It is less than a space href equal URL, which is a string. Notice a string cannot have a less than or greater than sign in it. So you can't have another tag inside of that href. Cannot. So make sure I phrase that. Cannot. And then you have text in between. Again, notice the text can be other tags. And then the end anchor tag. And then a URL is simply a string. Okay. Any questions on this part? You have different pages, you're going to parse it, and then just tell me if it's balanced or not. Real quickly, I've given you some boilerplate code. Let me show you what it does first. If you type in make, and you do HTML pages star, or actually page index, it says parsing pages. Pages is not balanced. That's because this code doesn't work, because you haven't implemented it yet. But it does tell you it's not balanced and how many pages it can visit. Again, this is not correct because we haven't implemented the code. But I wanted to show you the way this worked. Also, you can do a bunch of HTML pages, and it'll do all of them. Notice it's doing a parsing routine because it's going to take the page and give it to a parsing function for you and tell you to parse it. And then it's going to ask you if it's balanced and how many pages it can visit later. Okay. We'll get into the code a little bit more. Actually, no, let's look at the code now. So main, this might be somewhat confusing, but this part right here is what it does is for every argc, aka every argument to the program, it gets the page, it finds it, and then it calls a .parse function. Okay, HTML parser, what is that? Well, an HTML parser is part of this HTML parser class. So let's back out of here real quick. Source HTML parser.hpp. This is the class you are implementing. So there's a parser, default constructor, default or a destructor, a parse function, which is a string of the file name, is balanced, again passing a string for the file name, and page visit amount. And we haven't gotten to that yet, but there is a third function. That one is going to be the number of pages you can visit. We'll get to that momentarily. But the parse function, and I'll go and look in the CPP just so you can see, I've stubbed it out for you. Obviously, there's no code there, so this is wrong, but I've given you something to begin with. So the first thing that happens is it goes through every page and calls .parse. So the point of this is that you can do your pre-processing on the pages as much as you want right now. Any pre-processing you want. So I give you all the pages and you parse them. So this program's always going to parse them first. Then, after that, it's going to go through it again, get the page, and then say, is it balanced? It's going to call your parser.isBalanced on the page, and if it knows it returned a Boolean, so if it's is balanced, it avoids printing not, and if it's not balanced, it does print not and then balanced. And then page visit is the number of pages it can visit. And that should be the end of the code. Yep. Make some sense how the setup is here? Great. So again, HTML test, pages star. Parse knows it parses all the functions first, and then for each one it asks if it's balanced and how many pages it can visit. And it goes and prints them out for you. All right.
What's the point of the parsing function? Is that just a nice event, or like what's?
So the parsing, okay, the parsing is to let you pre-process the page any way that you want. There may be, you may want to ingest the page, and maybe you want to keep track if it is balanced, keep track of how many pages you can visit, or whatever you want to do. You don't have to implement parsing. It is there as a convenience, because some implementations do prefer to do pre-processing before it does is balanced or how many pages it can visit. You don't have to use it. The two functions I'm grading are balanced and can visit. All right, so one is balanced, hopefully makes some sense. Now that we have an HTML parser, write a web crawler, basic one, to determine the number of unique pages. Again, unique. That means if you've already visited the page, it doesn't count a second time. So unique, you only count each page once. Pages that can be visited from a certain page. For example, if I were to put this in, notice that the star basically evaluates this as well. Parsing, HTML Pokemon is balanced, it can visit one page. The end is balanced, can visit 0 pages. Not balanced is not balanced, it can visit 0 pages. If a web page is not balanced, then don't keep track of where you can visit. It can't visit any pages, it's not legitimate, and we will just assume a web browser should reject the page. Obviously modern ones don't, but to keep our life simple, if it's not balanced or it doesn't parse, it can't visit any pages. The index is balanced and can visit 2 pages. All right. So Pokemon, the end, and index are balanced, while not balanced is not. Since not balanced.html is not balanced, we say it can visit 0 pages since it does not parse. Also, while an example is not given, if the link is not visitable, i.e. the page does not exist, then do not count towards that as a possible link to visit. Here's the explanation of the visit. The end has no links, so the visit amount is 0. Let's go ahead and look at it. Pages. The end. There's no anchor tags. So obviously it can visit 0 pages if you are on that page. Not balanced has no links since not balanced. Pokemon can visit 1 page, the end, which is valid, and a dead end. So pages, Pokemon, it can visit the end. All right, cool. And that's 1 link it can visit, and the end cannot go to any more pages, so it's just 1. That's why Pokemon's 1 page. Index has 1 link to Pokemon, but once you go to Pokemon, you can then go to the end. So index can visit 2 pages through indirect link. So that's why index can visit 2 pages. Hopefully you can now see why this is not a simple how many anchor tags there are. It's okay, now we have to go evaluate how many pages it can visit. Keep in mind the visit amount is the amount of unique pages that can be visited from a certain page. I.e., if one web page either links to itself or eventually loops back to itself, when you come back to itself or to a page you've already visited, it doesn't count. All right, how are we doing on that section? Yes?
So if we have, when we look at index.html, should it still count the?
So if we, good question. So we just did HTML test on index and no other pages. The number should be 0 because that was not part of our page listings. Great question. Any other questions?
What was the question and answer again?
So if we took this right now, but we ran the program on just pages/index.html and did not pass anything else, then index would have been able to visit 0 pages because it wasn't part of our repository of pages.
Okay.
Okay? So yeah, the pages given to the parser or to your test program are all the pages that exist. No matter if they actually exist on the hard drive, those are the actual ones. Great question. Any others? All right. The first part of this project requires you to read from a file and parse out the input. This may seem daunting at first. Whoops. Daunting at first, but there are a couple things to help you out. This is not meant to be a compiler's course, although I've been tempted many times to make data structure a compiler course. Because, the data structures map so well to compiler writing. Like, every single one of them just maps beautifully. But that'd be a little too much work. All right, tags shall always begin with a less than, and end with a greater than. By the way, these rules are just to make your parsing life easier. Tags do not have a less than or a greater than between the starting less than or greater than, no matter what. Even if you have quotes, backslashes, whatever, there shall be no less than or greater than in between those two. What that means is, once you see a less than, read every character until you get to the greater than. That's your tag. All right? You don't have to do any weird escapes or whatnot. All tags except the anchor tag will have no attributes or white space. So the attribute, by the way, is this thing where you have a key value pair happening. Only the anchor tag has that. None of the other tags have that. That means bodies shall always be in this format and have no white space. So you don't need to call .trim or anything. The characters have to be strictly in this format or it does not count. The anchor tag will be strictly in the format less than a space, href equal file name, no space, greater than. In other words, only one space between the anchor, the A, and the href. It has to be strictly in that format. I will guarantee that the pages I give you are strictly in that format. If you encounter a tag that's not valid and the page is not balanced, it can visit 0 pages. It's not balanced. We're done. I will ensure all tags are lowercase. So you don't have to call .2 lower, or if you really want to deal with upper, you can. You will need to ignore the white space. And what I am talking about is, notice that there were tabs here. This is legal, as well as, oops. That's fine as well. I mean, it's not tabbed out correctly, but that's okay, because it's still balanced. I simply tabbed it out or spaced it out for you so it'd be easier for us to read. But in order to do that, your parser will have to ignore white space. The way I do that is parse or read in everything one character at a time. And if you're building a tag, make like a tag string or something that you're adding to. The reason for that is when you're in the general parse mode, where you're not in between a less than or greater than sign, if you encounter a space, a \t, that's a tab, \n, that's a new line, a \r, it's a carriage return. Ignore it. Just move on. And then that'll get you through all the white space. Okay. How are we doing?
Yeah, so when you're crawling through this, seeing how many links there are, yeah, you go inside an HTML page from if that page isn't balanced, you should just count that page as 0.
Is 0 and does not exist. So if someone tries to go to it, it doesn't work.
Oh, okay, yeah, so.
If it's not balanced, it doesn't. It just ignore it completely.
So you can't even go to it. Okay.
Yeah.
All right.
Let's see. Okay. Any questions on the parsing part before I do general project question or general project? All right, I'll do the general project real quick. So far, we use arrays, linked lists, pointers, stacks, and queues. You can definitely get 100 on this exam or this project by using just those. Chances are you'll be using more than one of them to solve this problem, but you will only need the ones listed. If you are familiar with the STL, you are free to use vector, stack, queue, and queue from the STL. Oh, and list. List should have been in there. You may use list from the library, but don't use anything else, like their HTML parser. Warning, data structure projects are significantly more demanding than labs. Imperative you start thinking about this project now. If you hit a roadblock, and you will, please come talk to me. When you talk to me, be prepared to show me what you have thought of so far. If you come to me with an idea, I will guide you to a good solution. If you come to me without an idea, I will tell you to keep thinking about it. Keep in mind there are many good variant solutions to data structure projects. Hopefully that should sound very familiar. Make sure you write some test cases, please. Add to GitHub. You have 2 weeks. So this is much shorter than Project 1. I don't know what happened this semester, but somehow our schedule got mixed up, and so we have to shorten some of the projects. This one's going to be only 2 weeks, and your next one's going to be 2 weeks as well.
So the 2 easy projects that were rumored to be easier than the other 2 are a whole week shorter?
Yes. Well, not a whole week. Usually you have 2.5. Okay. Any questions on this one? No questions? Okay.
So the only tag that we don't ignore white space and total space is to be the
Anchor.
the link.
Yeah, the anchor, or the link tag, yes.